All right, guys. So I'm going to talk about some of the rules as far as exponent rules go as you're going to need to know going forward. This was not covered last year in Algebra 2, so what we're actually doing right now is Algebra 2, not pre-calculus. So we're going to do exponent rules. And what I'm going to do is I'm going to list out 6 or 7 of the most important rules that you're going to need to know before we get to logarithms. And I'm going to give you an example of each of those, and then we're just going to kind of dive into what actually we need to do because I don't have 2, 3, 4 weeks to spend on exponents like we do in Algebra 2. So the first rule is going to be a to the power of m times a to the power of n. And that's always going to be a to the m plus n. Now here's the key. If you notice a right here, it's the same letter. That means it has to be, that's called a base. It's going to have the same base. So if this would be like, say, 5 to the third power times 5 to the second power, it's going to be the same thing as 5 to the third power plus my second power, which then would simplify to 5 to the fifth power. So that's how we could actually use this rule. But the key is this base has to be the same. All right. So the next rule let's look at is, let's say a to the power of m to the power of n, a power to a power. Well, that's the same thing as saying a to the m times n. So let's use our example here. We have 5 cubed to the second power. We can actually rewrite this as 5 to the 2 times my 3 to the third power, multiply them, which will give me 5 to the sixth power. So there are 2 of your most basic rules, and these are the ones that come up quite a bit. There's another one that comes up quite a bit, and a lot of kids say it's like distribution property. It is, but it isn't. It's if I have 2 different numbers, say ab to the power of m. This was the same thing as saying a to the power of m and b to the power of m. So this exponent goes to everything inside the parentheses. Now, if you notice you're multiplying here, you're not adding. You can't do this if you're adding. This only works if you're multiplying. So this would be something like 5x to the third power. This is really 5 to the third power times x to the third power. 5 to the third power would be 125x cubed. So there are 3 rules right there. The next one let's talk about this. Any number to the 0 power is always 1. Any number to the 0 power is always 1. So we can have something absolutely crazy like x to the 17th over 9. And as long as here my a cannot equal 0, as long as this part right here would not equal 0, meaning x could not equal 0, this will, to the 0 power, this will always just equal 1. It's just a rule. We just need to know the rule. A to anything to the 0 power is going to equal 1 as long as it's not 0 to the 0 power. We don't want to do this. 0 to the 0 power, we don't want to do that. You'll learn to do that in a different math class. All right. Another exponent rule. Let's say we have a to the negative 1. This is going to be the same thing as, or a to the negative m. It's going to be the same thing as 1 over a to the m power. This negative means we're taking the reciprocal, because this is really a to the m over 1. We're going to take the reciprocal of this. Good God. All right. So we take the reciprocal of this. Now, of course, we know our a cannot equal 0 because we can't have 0 in the bottom part of a fraction. All right. So what if we have something like a over b to the power of m? Same thing as a to the power of m over b to the power of m. I feel like I'm missing something. All right, so this one's kind of like the same one with multiplication, but this is division. So it's the same idea. Now say we have a to the power of m over a to the power of n. This is going to be a to the m minus n. So I'm going to look at an example of this one here. So let's say we have y to the 4th power over y to the 6th power. Now we know we can reduce this down, which isn't terribly bad. But if we do this in terms of exponents, we can write this as y to the 4 minus 6 because of this right here, which then gives me y to the negative 2. Now you come back to this rule right here, and this negative means I need to take the reciprocal, so I'm going to write it as 1 over a to the m. Well, my a here is y, and my m is 2. So this would be 1 over y squared. And voila, you're done doing this with exponent rules instead of just trying to cancel them out. You're just going to subtract your exponents. And the last rule, one of the rules we use quite a bit, is going to be the nth power of a to the m. We're going to write this as a to the m divided by n. So you actually are going to have a fractional exponent, like 3/2 or 2/3 or something along those lines. An example of this would be something like the cube root of x to the 4th. We would write this as x to the 4/3 power, because this mathematically is actually easier to deal with as you advance in math as the cube root of x to the 4th. So what we're going to do now is I'm going to make a whole bunch of videos of how to use these rules, how to rewrite things, simplify things along those lines, and then we're going to get into solving these by using what's called either the property of equality or one-to-one property. It just depends on who you talk with. They really mean the same thing. So those are all your exponent rules that you're going to need to know. They're not terribly bad. Most of them are kind of the same. This one is really the same as the product one. If you think about it, AB to the M is the same thing as A to the M, B to the M. So you're multiplying here. This really is just A times 1 over B M, which then this goes to both of these because it's times. It's really just the same rule. And then here the subtraction is just like the sum rule. All right, so let's dive into some more videos. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.